Welcome to Science Access. In today's class, we're talking about valency and oxidation number. If you know you are new to this channel, please kindly press the subscribe button and put on the notification so that you get notified when I post a new video. What is valency? Valency of an element is the number of chemical bonds that an atom can form with other atom to form a stable or to achieve a stable electronic configuration. They usually achieve this stable electronic configuration by what? Satisfying their outer shell. You know, there are rules that you can actually follow to satisfy the outermost what? Shell of an atom. For example, the first outermost shell achieve or can attain maximum of 2 electrons, the second 8. So there are rules regarding that. You can watch my video on atomic structure before watching this and to make you understand it better. Now, when you talk about oxidation number, it simply refers to the number of electrons that is either gained or you lose to form what? A stable what? Chemical what? Compound. I'll use some structures to explain this simple fact. Now, let's start with this simple example. This is sodium chloride. This is sodium chloride. Now, if I ask the simple question, what is the valency of chlorine in this compound? And what is the valency of sodium in this compound? And I can also ask the question, what is the oxidation number of chlorine in this compound? And what is the oxidation number of sodium in this compound? Let's take a look at how to solve this simple problem. Now, sodium, what is the atomic number of sodium? Atomic number of sodium is actually 11, while that of chlorine is 17. You can take a look at that in the periodic table. All right. So let's now let's draw the structure of sodium and let's draw the structure of chlorine. So the structure of sodium, remember the number of electron, the number of proton, which is the atomic number, is equal to the number of electrons. It simply means that chlorine has 17 electrons and sodium has 11 electrons. So let's draw the structure of sodium. This is the nucleus. I'm presenting with N. All right. Inside the nucleus, there is proton and neutron. Inside the nucleus, you can take a look at the atomic structure video. So this is the nucleus. The first shell, as I said earlier, takes a maximum of 2 electrons. So out of the 11 electrons, 2 is out. How many is remaining? 9. So the second shell can take a maximum of 8 electrons. So we'll represent that here. So if 8 electrons enter the second shell and we have 9 here, is remaining 1 electron. So I have 9, then remaining 1. The last one will now go into the third shell. Now let's draw the structure of chlorine. So this is sodium. Let's draw the structure of chlorine. The first one is the nucleus. The second takes 2 electrons. The third definitely will take 8 electrons. So we are using a different symbol to represent the electron. While the third shell will take what? Remember, we have 17 here. If the first shell takes, out of 17, if the first shell takes 2 electrons, how many will be remaining? 15. The second shell takes 8. How many will be remaining? 8. So it will now be remaining 7. So the third shell will now take what? The 7 electron. So we now have the 7 here, here. That's 1, 2, 3, 4, 5, 6, 7. So you realize that for these 2 elements, or for these 2 atoms to combine with each other, this third shell can take a maximum of 8 electrons. So it's easier for sodium to give out 1 electron than for chlorine to give out 7 electrons. So in this case, sodium will actually lose 1 electron. Sodium will lose 1 electron. So this will now come here. So we'll now have this here. So this will now be out. This is now the electron that is here. So remember, since sodium have actually lost 1 electron, it will now become positive. While since chlorine have gained 1 electron, it will now become what? Negative charge. Now the bond between these 2 is this charge, is this force of attraction between this positive and negative word charge. It's a single word bond. So now let's go back to the question. What is now the valency of sodium? The valency of sodium is actually 1. You have +1 here, or which is also plus. All right. So the valency of sodium in this case is 1. What is the valency of chlorine? Remember, when we talk about valency, we said the number of bond. The number of bond. That valency of an element is the number of what? Bonds. Specifically refers to the number of what? Bond an atom can form with another what? Atom to form a stable electronic configuration or a stable structure. So for them to form a stable structure, this third one can have a maximum of 8. So he wants to be complete. He wants to be satisfied. So it will now, this one also wants to be satisfied, right? This wants to be satisfied and this wants to be satisfied. This one it's easier for this one to lose the 1. Once it loses the 1, the outermost shell now have 8. So this is satisfied. And once this gain the 1, the outermost shell of this now have 8. So both of them are satisfied. Well, in this case, they form a single bond. Remember, they just lost 1 electron, and this one gained 1 electron, which is single. So we now have a situation where we have +1 here and -1 here. Single number of bond is what? A single bond. So we now have the valency of this is actually 1. If you are asked about the valency of this, it's also 1. Now, there are some mistakes that are usually made. In some cases, they will now put here as -1. Please note, it's just the number of bond. So you don't need to put the minus. But what about if I now ask for the oxidation number of sodium in this place? The oxidation number is actually the +1. Note that the valency is 1, the oxidation number is +1. All right. While the oxidation number of the chlorine in this atom is actually -1. So this is the simple difference between valency and oxidation number. Valency is concerned with the number of what? Chemical bond an atom form. An atom can form with another atom to form a stable electronic structure. Let's quickly clean this and take a look at another example, such as calcium chloride. So the formula for calcium chloride is CaCl2. All right. Formula for calcium chloride is CaCl2. So what is the atomic number of calcium? And what is the atomic number of chlorine? We know before, or as we earlier stated, chlorine has what? 17. And calcium has 20. So let's draw the electronic structure. We'll use our previous structure. This is the nucleus, the first shell. Remember, here is 20, right? Once you put it, now remaining 18. Second shell. This is the third shell. Now, this is 2 plus 8 is 10. Plus 8 again is 18. So it's remaining 2. So the last shell will take what? 2. So let's put it 2 here. While for chlorine, we repeat what we have done before. This N, this is what? The first shell. Okay, let's use a different symbol. This is the second shell. 8. And this is the third shell, which takes what? 7. Takes 7. Now notice, this one have 2 in this outermost shell, but this need 1, right? So it will donate, 1 will come to this place. We donate this to this. I will now have, but we're still having, this one is now stable. But here, we still have 1 electron in this outermost shell, which means this is not stable. So this one will also go to another atom of chlorine. So we'll now have another one here. And we'll now have another one here like this. This 8. And this is, remember, chlorine is actually 17. So the first to go into here, Second 8 into here, that's 10. The last one is 7. 1, 2, 3, 4, 5, 6, 7. So this second atom of chlorine will now gain another electron. How many bonds do we actually have? We have 2 bonds here and here. So the valency of this is actually 2 in this compound. But what about of chlorine? This is just combining with this, right? 1 bond. So the valency of chlorine is actually still 1. Because if you want to consider the 2 bond, the 2 bond will now be 2 bond divided by what? 2 atom. What do we have? Is still 1. So the valency of calcium in this place is what? 2. While the valency of what? Chlorine is also what? 1. Remember, though we have 2 bond, but one is attached to 1 carbon and the other one is attached to 1 atom, the other one is attached to what? The other atom. So it's simple. This has only 1 bond attached to it, or a force of attraction positive. This gain only 1 what? Electron, and this is also gaining 1 electron to form a bond with this. But this is losing 2 electrons, so this is 2, and this is 1, this is 1. If you want to combine, if you want to say, okay, it's actually 2 bond, no problem. Use it to divide by what? The 2 atom, you also have what? The 1 as your answer. So it's a very simple concept about valency. Why, in terms of oxidation number, if you have to calculate the oxidation number of chlorine in this case, it's still simple. Let's do it anyway. Calcium, we know we have +2, right? So we now have +2. So we now have +2, 2 atom of what? Chlorine, right? So this one can cross. This can actually what? Cross the what? The equal to 0, right? So you can take this one across the equal to 0. And I have 2 chlorine equals to what? -2. 2 chlorine equals to -2. Divide both sides by what? 2. So this here over 2, this here over 2. This cancel this. Now I have Cl is equals to -2 all over what? 2. Now I have Cl is equals to what? -1. So the oxidation number of chlorine here is still what? -1. Please take note of this. It's a very simple concept. I will have to give you a little assignment. Just drop your answer in the comment section, or you can just show me your work, take a picture of your work, send it to biologyaccess@gmail.com. So this is the simple assignment. Simple assignment. All right. What is the oxidation number and the valency of aluminium in this what? Compound? If you solve and it's challenging, just send a mail. I will give you the correct answer. All right. But you have to try first. Thank you for watching.